Right. The second one, our previous video, we discussed we discussed about non-uniform distance and time graph. Distance and time graph. Here, observe once in non-uniform motion, the slope is like a curved line. Here, curved line means there is a change in the speed of the body takes place. Change in speed of the body takes place. Then the change in speed of the body we can call the acceleration. So, in case of non-uniform motion, the body is accelerated. The body is accelerated. Means it is in the acceleration. It is in the acceleration motion. A body with non-uniform speed. A body with non-uniform speed. Then we can say that the body moving with acceleration or accelerated motion, because we know change in velocity or change in speed we can consider as acceleration. This is the one important point regarding to distance time graph. Distance time graph. Then the second one, speed time graph. Speed time graph. Speed time graph. Sometimes it is also called velocity time graph. Velocity time graph. Velocity time graph. Here we can explain the motion of the body by using the speed time graph in three cases. Three cases. They are when the speed of the body remains constant. If the case one, speed is constant. If speed is constant, how we can draw the graph? Then one more, speed of the body. Second one, speed of the body changes. Speed of the body changes at uniform rate. At uniform rate. Then the third one is speed of the body. Speed of the body. Speed of the body changes at non-uniform rate. Non-uniform rate. So these are the three cases we have. One is if the speed of the body changes at uniform rate, if the speed of the body is constant, if the speed of the body changes in a non-uniform rate. Right. So let us draw graph between speed and velocity. Speed and velocity. Speed and velocity. If the speed of the body is constant, so on x axis we have taken time, and y axis we have taken speed or the velocity. If speed is constant, if speed is constant, that means there is no change in the speed of the body. There is no change in the speed of the body. In this case, when we draw the graph, we get a straight line. We get a line which is parallel to the time axis, which is parallel to the time axis. So speed here taken as A, here if you taken as B, here taken as B, so OA, so we can assume that a point C, a point C here. So time on x-axis, speed on y-axis for a constant speed. For a constant speed, that means no change in the speed. That means at a constant speed, when we draw the graph, it gives it constitutes a straight line which is parallel to the x-axis or time axis or time axis. In other words, the speed time graph a body is straight line parallel to the time axis or the x-axis, then the speed of the body is constant. So when we draw a graph between the speed and the time, between speed and the time, in the graph, if you get a line, a line with a straight line which is parallel to the x-axis, which is parallel to the x-axis, parallel to the x-axis, so represent the body is moving with constant speed. The body is moving with constant speed. So if there is no change in the constant, if there is no change in the speed or the velocity of the body, then here we have no acceleration. Therefore, no acceleration. Hence, there is no question about finding the acceleration. No question finding about the acceleration because of there is no change in the speed or velocity. Here in the distance time graph, we are able to calculate the speed or the velocity, and the most important thing here, by using this speed and time graph or velocity time graph, we have to calculate the acceleration. We have to calculate the acceleration. But means the slope in the time graph, the slope in the speed and time graph or velocity time graph gives us an idea about the acceleration. But in case of if the speed is constant, the speed of the moving body is constant, we get a straight line which is parallel to the time axis or the x-axis, represent no change in the speed of the body. So here we no need to calculate. Here we no need to calculate acceleration. No need to calculate acceleration. So from this we can write speed is equal to we know distance. We know distance by time. Distance by time. So from this we can write distance is equal to speed into time, speed into time. So what about the speed here? To find the distance traveled by a body at point C, to find the distance at the point C, we need to draw one perpendicular to x-axis from any point on the straight line which is parallel to the time axis. So this represent the speed. This represent the speed. So CB represent the speed. So CB represent the speed. Here this CB nothing but speed of the body equal to OA. So CB is equal to OA. Speed at point C. Speed at point C is equal to CB, that equal to A. Then what about the time? OC. What about the time? OC. Speed at C. So time. Time at C equal to OC. This OC equal to AB. This OC equal to AB. So distance calculated, speed how much? OA. OA into OA into OC. OA into OC. So in this way we can calculate the distance travel. Distance travel. So represents here OA. It looks like a rectangle. It looks like a rectangle OA BC. Look like a rectangle OA BC. OA BC. So if it is the length, if it is the width, so let us consider like L into B anukunde. L into B. So we know the formula length into width is equal to area of rectangle. Area of rectangle. So in this speed time graph means when speed is constant, we get a rectangle shape. We get a rectangular area. That rectangular area that is equal to, so that represent distance covered, distance covered, distance covered by a body is equal to area of rectangle, OABC. OABC. So instead of calculating the acceleration, here we calculated the how much distance traveled. How much distance travel. So, in speed time graph, the area enclosed by the speed and time graph, in the distance and the speed and time graph, the the area enclosed represents are useful to calculate the distance traveled by the body. Distance traveled by the body. So if it is taken as velocity, time, acceleration, right, instead of distance we need to calculate the displacement. Speed and time, distance, velocity, time, displacement, but both consider here same only. Both consider here same only. Speed at point C along x-axis, speed at point C along y-axis, here we calculated. So how much distance is traveled by the body and formula speed equal distance by time. So from the distance is equal to speed into time. Speed into time. This is the formula. Finally, we have to calculate the distance traveled. How can you calculate? So in a speed time graph, the area enclosed by the speed time curve on the time axis. This is the curve. This is the curve line and this is the time axis. Time axis gives an idea about distance traveled by a body. Distance traveled by a body. Right. So this is about what if the speed of the body is constant. If the speed of the body is constant. Then let us discuss two more. right? So distance time graph gives about the calculating speed of the body. Calculating speed of the body. The slope is a straight line. The slope is straight. Then we can said to be the body is in the uniform motion. Whereas in case if the distance time graph is a curved line or the parabola gives us idea about the non-uniform motion. Non-uniform motion. Thus, coming to second case, second graph, speed and time graph. Speed and time graph. We can draw the speed and time graph in three cases. If the speed is constant, the between speed is constant. When we draw the graph or when we plot the graph between speed and time, if we get a straight line which is parallel to the time axis, represents the body is in the uniform speed. In the uniform speed, that means the speed of the body is constant, so no acceleration. But when we know the speed of the body at a particular point like C, we need to draw one perpendicular from the straight line which is parallel to the time axis. It forms a rectangle. So the area of this rectangle gives how much distance covered the body. Then coming to the second case. Speed increases with the uniform rate. Speed increases with the uniform rate. What happens if the speed or the velocity increases with a uniform rate? With uniform rate. So when a body moves with uniform acceleration, its speed may be equal amount in equal intervals of time. In other words, the speed becomes directly proportional to the time. So the speed time graph for a uniformly changing speed or uniform acceleration will be straight line. Right? So when we draw the graph between speed and velocity, speed and time, if we get a straight line, represent that the speed increasing, or the velocity increasing uniformly. That means the body is in the uniform acceleration. Uniform acceleration. So time graph speed changes. Changes with uniform rate. So here O, let us consider a point A. Then here taken as B. Once you draw one perpendicular line to time axis X. So time and speed. So this slope of the speed time graph, speed time graph represents that speed changes with a uniform rate. So speed increasing uniformly, then we can say that, then we can uh, then we can say that the body is in the uniform acceleration. To find the value of acceleration, to find the value of acceleration from the speed and time graph, from the speed and time graph of a moving body, so we need to draw one perpendicular QP, or instead of QP we have taken AC, one perpendicular AC to the time axis, and a parallel line to time axis, or one more perpendicular line to speed y axis, OB. So we know that acceleration acceleration is equal to change in velocity, change in velocity change in velocity by time, change in velocity by time. So what is the change in velocity here? Change in velocity, the change in velocity is equal to AC, that equal to AC by, or OB, AC or OB. This is both are same కాబట్టి then we can take it as AC. AC by time. Time represent OQ. Time represent OQ. This is the time OC. AC by OC. Here AC is nothing but to OB. OB is nothing but to speed or velocity. This velocity is equal to the perpendicular line AC. Both represent the speed or the velocity. Here OC is represents the time. So AC by OC. AC by OC. So in this way we can calculate. We can calculate. But AC by OC is the slope or the gradient of speed time graph OP. Therefore, we conclude that in a speed time graph, the acceleration given by the slope of the graph. So here AC by OC gives a slope of speed and time graph. That slope AC by OC is slope of speed and time graph. Speed and time graph represents acceleration, represents acceleration. The slope in a speed and time graph or velocity time graph gives us about acceleration. In a distance time graph, it gives us a speed or velocity. So this is for speed changes uniformly. If the speed increasing, then what about if the speed is decreasing? If the speed is decreasing, at x-axis time, at y-axis speed, then in case of the speed of the body or the velocity of the body decreases, what will happen? We get a graph like this. So O here taken as A, here to be taken as B. Alright, OA, OB. So here what will happen? Speed decreasing. Speed decreasing. Speed decreasing. So speed decreasing. So change in the speed. Change in the speed is called change in the speed called acceleration. Here the speed or the velocity decreasing. The speed and velocity decreasing. Speed and velocity is decreasing. So the velocity decreasing, we already discussed. There will be change in the velocity is decreasing. We can say that the body is in retardation or is negatively accelerated. Negatively accelerated. So a speed time graph a body, a straight line sloping upwards. A straight line sloping upwards gives positive acceleration. In a speed time graph, the change in velocity or the speed, change in velocity of the speed, straight line moving, straight line sloping down. If the slope is upward, positive acceleration. If the slope is downward, then it is the negative acceleration. It is the negative acceleration. So if the speed is changes uniformly, if the speed is changes uniformly, if we get upward straight line represent positive acceleration. If the speed changes, then if it is gives downward slope represent negative acceleration. Negative acceleration. So it is in the uniform negative acceleration. It is in the uniform positive acceleration. Positive acceleration. So by using these graphs, can we calculate how much distance is traveled by the object? How much distance traveled by the object from the speed and time graph? So here, if the speed is constant, we calculate the distance or displacement covered by the body. How? By taking the area of rectangular, right? Right. So, let us calculate distance traveled, distance traveled means calculating how much distance traveled by the body if speed changes with uniformly. So as explained earlier, the distance traveled by the body in the corresponding point Q will be equal to the triangle. So in this case, how much distance traveled is given the area of this rectangle OAC. The area of distance traveled is equal to area of a triangle, OAC, OAC or OAC, OCA, OAC or OCA, whatever, OCA or OAQ. So it is right angle triangle that is equal to 1 by 2 into 1 by 2 here. OC is the base. OC is the base and AC is the height. We know area of right angle triangle half into base into height, half into base into height. So distance traveled by the body in case if the speed changes with uniform rate, in case with speed changes with uniform rate, distance traveled by the object, we have to use this formula. The distance traveled by the body is equal to area of a triangle, area of this right angle triangle. The slope represent about the acceleration. The slope represent, the slope is acceleration. The slope is acceleration. The area of triangle, area of triangle is distance traveled. Distance traveled. Right? Here, this slope gives acceleration and this area is given as a distance traveled. So in this way we can calculate the speed, we can calculate and we can know acceleration. Is it a positive acceleration or the negative acceleration? And also we calculate distance traveled. Distance traveled. Right? Then let us discuss the third one.